everyone, welcome to our channel Knowledge Hub. Please subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your CBNST class. This has been the class 4 where we had done in the last classes. We had done in class 3. In that we had started with unit 1. The name of the unit is the computer arithmetic errors and the roots of equation. The subject name we have is computer based numerical and statistical technique, where we had started with unit 1 in the last classes, and we have covered up the questions as well in terms of numerical as well. So now we're gonna start with the next few questions as well. Before starting with this, it's a huge request to all the viewers to please go through with the subscribe button, and please like, share and subscribe our channel so that many and maximum people can get the information at once, and even you can also enjoy the video as well. So please like, share and subscribe our channel so that many maximum people can get the information at once, and even you can also enjoy the video as well. Start with the question today. You have to calculate the absolute and relative error in the following cases. In the comment you have to answer on the result. The true value is 1 into 10 to the power minus 6, and approximation value is 0.5 into 10 to the power minus 6. Second value we have, true value is 1 into 10 to the power 6, and approximation value is 0.99 into 10 to the power 6 as well. So we'll go ahead for the same as well here. We'll go ahead here. Calculate the absolute and relative error in the following cases, and comment on the result. So first we have here true value equals to 1 into 10 to the power minus 6, and approximation value equals to 0.5 into 10 to the power minus 6. And second we have for this, the true value equals to 1 into 10 to the power minus 6. Sorry, this has been the plus 6 here. So approximation value equals to 0.99 into 10 to the power 6 positive 6. For absolute error, we'll find it out here for the first one. So absolute error equals to true value minus approximation value equals to 1 into 10 to the power minus 6 minus 0.5 into 10 to the power minus 6 equals to 0. Also here for the same, and that we have to talk about it, and which is 0.5 into 10 to the power minus 6 we have. So hence relative error will be your relative error equals to absolute error upon true value, which is equals to 0.5 into 10 to the power minus 6 upon 1 into 10 to the power minus 6, that is equals to 0.5. For the second we talk about it, that we have absolute error equals to true value minus approximation value, which is equals to 1 into 10 to the power 6 minus 0.99 into 10 to the power 6 equals to 10,000. So hence relative error will be absolute error upon true value, which is equals to 10,000 upon 1 into 10 to the power 6 equals to 0.01. Now results and comments we talk about here now that I had asked you about in the question. So results and comments we have. So the examples: absolute error, relative error, comments we have to go ahead. Okay, for the first one, that is 0.5 into 10 to the power minus 6 is 0.5. Now the comments we have is your relative error is more. For second one is your 10,000, this is 0.01, and that is relative error is less we have. So for the first one, it is not possible to compare the errors in two computations with the help of an absolute error. And for the second, that the absolute of the second example seems to be quite large, but relative error is about 1/50th of the first example, and thus relative error is more useful. We'll go ahead for the next question we talk about it, which has been the second question of the session as well. The question is, find the error Ex and the relative error Rx, and also determine the numbers of significant digits in the approximation of the following. Where in the first case we have your let x equals to 2.71828182 and x bar is 2.7182. We'll go ahead for the same. The question is being, find the error Ex and relative error Rx, and also determine the number of significant digits in the approximation of the following. So we have for the first one, it is let x equals to 2.71828182, x bar equals to 2.7182. So for that we'll have to solve it out as well. So as x is equals to this and x bar equals to this, then error Ex equals to x minus x bar, which is equals to 2.71828182 minus 2.7182. We'll get the value 0.00008182. So relative error equals to absolute error upon true value, which is equals to 0.00008182 whole upon 2.71828182 here, which is equals to 3.00925 into 10 to the power minus 5. Now the significant digits are those which are the actual value and the approximation value that agrees is, and for that it will be x equals to 2.71828182 and x bar is equals to 2.718 that has been 8 2 here. So this is being like this. We have here, so x and x bars agrees to these 5 digits here, and as shown above, so x and x bars agrees to the 5 digit, and hence 5 significant digits are present in the approximation. We'll talk about the second one, which we have a question, another question we have for the same. Let y equals to 98350 and y bar equals to 98000. So for that, error y equals to y minus y bar 98350 minus 98000, which is equals to 350 here. On the same cases, we go ahead, we find out the relative error here, and that is being as follows. So for that relative error, it will be relative error equals to absolute error upon true value, which is equals to 350 upon 98350 we have, which will give 0.0035587. that we have your value as well. For the two values that are we have, so the two values are y equals to 98350 and y bar equals to 98000. So this 98 will be common here, and as shown here that y and y bar agrees to the 2 digit, hence 2 significant digits are present in the approximation here. Now we'll go ahead with the next question of these type only, and that we have here, which is being another question. The question is, let z equals to 0.000068 and z bar equals to 0.0000 here. So for the same, we go ahead here, that we have to talk about it. So with the same, we'll have find it out for the error as well. Error is equals to, which is of e of z, z minus z bar, which is equals to 0.000068 minus 0.00006 here. So for that, it will give you 8 into 10 to the power minus 6 here itself. And so we'll go ahead, relative error equals to absolute error upon true value, which is equals to 8 into 10 to the power minus 6 upon 0.000068, which is equals to 0.117647. So the two values are z equals to 0.000068 and z bar is equals to 0.00006 only. So this 6 will be common here. So for the same here, that we know that zeros after decimal point that are not considered as significant digit, and hence z and z bar agrees only to the one digit, that therefore one significant digit is present in this approximation here. We'll go ahead for the next question that we talk about it, which is being of course another important question here, and that is being the another important. And the question is what is the absolute error in summation, subtraction, and product and division as well. So we'll have to find out for this. That has been of course the important one. What is absolute error in summation, subtraction, product and division? that we have here. So for that here now let us consider the treatment of the absolute error in algebraic operations such as addition, subtraction, multiplication and division. For the first we have here is absolute error in summation and subtraction. Absolute error in summation and subtraction. So for that, let us define as the absolute error that is being EA, and if two numbers are added or subtracted, then the magnitude of the absolute error is the result is equals to the sum of magnitudes of individual that is absolute error. Let EA1, EA2, EA3 and EAN that are the absolute errors in n numbers. Then absolute error of the additions or subtraction of these numbers is to be given as, and then that is being followed as like this: EA equals to EA1 plus EA2 plus EA3 plus EAN. Now we talk about the another one which we talk about here, and that is being the second absolute error in product. Error in product. In absolute error in product, let there be two numbers with actual values of a and b, and let the absolute error in a is e, that is of e, we have EA1, and that is b and EA2. Then absolute error in the product EAB is given as, and which is being like we have EA equals to a, EA2 plus b, EA1. Now we talk about for the next one, which is being the absolute error in the division. Absolute error in the division. So for that, it is your absolute error in the division a by b is to be as given. Here we have EA equals to BEA1 minus AEA2 upon B2, which is B square. So this is what we have, and now we'll go ahead with another question. We talk about it. Find the approximation or maximum error in 5.43 into 27.2 here. So question we have, find the approximation maximum error in 5.43 into 27.2 that we have to talk about it, and which has been of course important one as well. So for that, here we have to calculate the error in product. For the same we talk about it. Here we have to calculate the errors in product. So let A equals to 5.43 and B equals to 27.2. So here A is equals to 5.43. So there are two significant digits after the decimal point, and hence the maximum error in A that will be plus minus 0.005. In another word, maximum absolute error in A will be EA1, which is 0.005 here. So similarly we talk about it here, that is similarly B equals to 27.2. so there is one significant digit after decimal point, and hence maximum error in B will be plus minus 0.05, and that is the maximum absolute error in B that will be here, and which is being of course written as EA2, that is being equals to 0.05. So absolute error in the product has been given. Absolute error in the product is given as EA equals to AEA2 plus BEA1. So putting the values in above equation, which is your EA equals to 5.43 into 0.05 plus 27.2 into 0.05 equals to 0.4075. So that the absolute maximum variance in the product is 5.43 and 27.2 will be 0.4075 that we have as an answer here. Now we'll go ahead with the next, and that has been the last question of the session here. So here we're gonna start with the next question, that is the area of the cross sections of rod is desired up to 0.2% error. How accurately should the diameter be measured? So we'll go ahead for the same. The area of cross section of rod is desired up to 0.2% error. How accurately should the diameter be measured? That we have to talk about it. So here for that the area A and the diameter D, small d, that are related as, which has been A equals to pi d square equals to pi d into d. For the same, that here the diameter is multiplied, that is your d x and d. The error is in calculation of the diameter is reflected into errors in area, where errors in area is 0.2% or 0.002. In other words, this error of 0.002 is obtained due to the error in product dxd. We know that the error in the product is given as, which is of EA equals to AEA2 plus BEA1. Here EA, that is 0.002, and that is the error of the product or the area of the rod, and A equals to B, which is equals to D. Similarly, EA2 is equals to EA1, which is equals to, of course, EA1. EA, that is error in the diameter of the rod, and hence above equation will be written as follows: EA equals to DED plus DED. Here EA equals to 2DED, so which will put a value 0.002 equals to 2DED, and that is being equals to ED equals to 0.002 upon 2D equals to 1 upon 1000D. So here there is the error in the diameter that should not exceed 1 upon 1000D here, that we have as an answer. So here we're gonna end up with this as well, and that we'll discuss the rest of the classes in the next coming classes, the rest of the topic of this unit as well in the next coming classes here. Other than this, CBNST we talk about, we had done your sociology, software engineering, we had done your in software engineering. Other than that, we had done your chemistry. In chemistry, we had done unit 1, unit 2, unit 3, unit 4, unit 5, unit 6, unit 7, unit 8, unit 9 as well, with the conversions, logarithms, anti-logs, element with the symbols, atomic mass, with the Muller masses, of course, and we had done your understanding the human being comprehensively, the human aspiration and its fulfillment as well. In that we had done unit 1, unit 2, unit 3, unit 4, unit 5 with your 2 marks possible questions. After talking about that, yes, we had done your quantitative aptitude. In terms of quantitative aptitude, where we had done in arithmetical ability, we had done operations on numbers, SCF and LCM of numbers, decimal fractions, simplification, square roots and cube roots, problems on numbers, problems on ages, stars and indices, percentage as well. In terms of reasoning, we had done in that reasoning we had done your verbal reasoning. In verbal reasoning we had done general mental ability and the logic reasoning. In non-verbal reasoning we had done series and logic classification, analytical reasoning, mirror image, water image, embedded figure, completions of incomplete pattern, figure matrix, paper folding, paper cutting, rule detection, grouping of identical figures, cubes and dice, participation as well. Figure formation and practice question set that we had done in your reasoning here, which we had completed as well, and that has been the important class. Of course, we are dealing with ER diagrams of different ER diagram, which has been important for you all, even though we had done your English vocabulary, which has also been important for you all, because this plays an important role, of course, and that will enhance your vocabulary as well as your communication skill and your skills as well. So stay tuned with us. Please go ahead with like, share and subscribe our channel, so that many and maximum people can get the information at once, and even you can also enjoy the video as well. So thank you, hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion on the comment box, and please like, share and subscribe our channel, so that many and maximum people can get the information at once, and even you can also enjoy the video as well. Thank you. Other in terms of coming towards the CBNST as well. In terms of CBNST, yes, we had done your unit. We are dealing with unit 1 here. In unit 1, which has been the name of the unit as I told you here, which is your the arithmetical ability. In same cases, we had started with unit 1, which has been the computer arithmetic errors as well. And this we had done your floating point arithmetic machine epsilon, that are epsilon, round off the errors, chopping errors, translation error, associative and distributive laws in the floating point arithmetic, inherent error, other propagation, numerical instability, and in roots of equation we'll have to do it. Secant method, neutral Raphson methods, and a fixed point iteration method for the simple roots and derivations of the rate of the conversions, and Atkinson accelerations of the conversion, modified Newton's Raphson method for the multiple roots, Bridge-White, that is your Bridge-White method for the polynomial, Weierstrass method for the quadratic factor, computer algorithm of these methods as well. In unit 2, we have to complete that interpolation, which has been the algorithm and the error analysis of the Lagrangian and Newton's divided difference interpolation relationship in the various difference operations, piecewise linear interpolation, cubic spline interpolation, natural spline, and then your Chebyshev's polynomial approximation, Langhaus economizations of the power series, and then after that we'll have to, in curve fitting we have to do it, that is the linear and non-linear least square approximation, third conditioning in the least square methods, gram schematic process of the orthogonalizations, computer algorithm of least square curve fitting. And the third is the differentiation, where we have to cover up the methods based on the interpolations and finite differences, and your Richardson extrapolations, integrations, errors analysis, and trapezoidals, and the Simpson method, Newton's course integration method, Gaussian integration method, that is your Legendre method, and Lobato integration method, and Radau integration method, error term in integration method as well. Unit 4 is your solutions of simultaneous linear algebraic equation, where we have to cover up the Gauss elimination method, third, and that has been the consolidated system and the conditions number that is successive over the relaxation method, rate of the conversions as well. Solution of the ordinary differential equation, where we have to cover up the single step method, Runge-Kutta second order, third order of the fourth order method, and multi-step method, and your predictor corrector method as well. In statistical technique, we have to cover up the statistical hypothesis, test of hypothesis, type 1 and type 2 errors, level of significance, test involving the normal distribution as well. So here we're gonna end up with, it's a huge request to all the viewers to please go through with the subscribe button, and please like, share and subscribe our channel, so that many and maximum people can get the information at once, and you can also enjoy the video as well. So keep supporting us as you had supported ours, and please go ahead with like, share and subscribe our channel, so that many and maximum people can get the information at once, and you can also enjoy the video as well. So here we go ahead with end up with this. Thank you. Hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Thank you.